Hello, in this video I'm going to talk about using LaTeX to write linked notes. So LaTeX has some packages where you can reference, say, theorems and definitions and also just general files from a note or from a LaTeX document. You can reference, say, propositions in a different LaTeX document. And so what you can do is you can use LaTeX to kind of write a obsidian kind of, you can program obsidian in LaTeX. And so that's what I've been doing. And over the past, 6 months or so, I've been, writing notes to do that. And so in this video, I'm going to talk about the software that I've written to do that and also give an overview of how you can do the same thing. So if you see here, this is kind of like the base directory of my sort of notes. And if I run this script managed by edit, then it's going to open the most recent note that I was editing. So this is just a kind of convenient function. And so this opens this note that's called custom written as generalized cyber written. So this is just something that I've been working on for my PhD. So I have a keyboard shortcut set up in Vim. So if I type leader P, then it opens the PDF. And so you can see this is kind of what the notes look like when you render the note. And here there's a hyperlink to a different note. So I have I don't want to define the generalized cyber written equations in this note, but instead I have them defined somewhere else. And so I can reference that note. So you see here that this is the definition that links to this proposition. And so this is really the main reason why I wanted to use LaTeX to kind of write these notes, is that I want to be able to reference the definitions. If you were doing this in Obsidian, then you could only really reference either like the section of a note or the note itself. And I feel like this is just kind of a cleaner way of referencing that works kind of better for maths, perhaps. Okay. So I think I also have, so you can see here that I can go back to the custom written equations from this generalized cyber written. So I have a part of them. This kind of referenced in section gets automatically rendered, and there's some nice things that works like that. So I have also these Hades written equations, which are also referenced by the custom written equations. And so maybe as an example I can show. So I should really have linked the custom written equations from this this note here. So if I wanted to add that in, then what I would need to do is type this command x hyperref. So the hyperlink text that I want is the custom written equations. And then I need to specify the ID of the note. So this is where the note is held. So the note title, so this tends to be something like no spaces but capitalized, so kind of camel case. And I think the note title was custom written equations. Yep. So now if I render this, then you see it has a link to the custom written equations. And you see here that this render updates file has also rendered the custom written equations. And what that has done is it will have added the kind of referenced in section to the custom written equations. So you see now that the custom written equations, you can see that I've linked to these from this document. So this kind of referenced in section is just kind of a nice to have feature for looking at the notes. Another feature, another kind of nice to have thing that I implemented was I implemented kind of Obsidian's network view just kind of very quickly. So I need to use a virtual environment to get the Python packages, but so once I run this, then I can run network.py, and then this gives me a kind of network view of the nodes. So, I mean, it's a bit messy kind of around here, and I need to look into kind of better algorithms for rendering this kind of network view. So, yeah, it's kind of a non-trivial task to get this working. So to get kind of a nice, view of the nodes. Right. So if you wanted to kind of use this software yourself, then we can go to the GitHub repository. So the GitHub link will be in the description, but it's just Alfred Holmes TeXNotes. So TeXNotes is the name of the software. And then we can just clone the GitHub repository here. So just copy the link, and then I'm going to make a new folder somewhere. So if we clone this repository with git clone, so you probably have Git installed. If not, then you'll need to install it, or you can just download this as a zip file somehow, I think. Yeah, so you can download it as a zip instead. So this is cloned the repository, right? And then so you get a whole load of stuff here. And then if we so what we need to do now is we need to install the Python dependencies. So this uses some kind of libraries that aren't included with Python, so you need to install these to run the software. So to do that, you need to set up a virtual environment. So I have some, so I can use virtual env venv. So what this does is it makes a kind of local copy of Python so that you can then install Python libraries only in this folder. And so basically what happens is maybe TeXNotes will need a particular version of some software but your system also has another version of that library installed. And so using the virtual environment means that you don't get any conflicts like that. And then to enter into the virtual environment, I can use source venv bin activate. And then it's always good if you spell source correctly. So once you've done this, then we can install the requirements. So it's just pip install requirements. I need to change directory into. Okay, so if I change directory into the TeXNotes folder, then this will work. So pip install requirements. Okay, so this will just install the required things. So now what I'm going to do is I'm going to make a new note. So I can do that by typing manage.py new note, and then let's call the new note index. Now if I do manage.py edit, then this is the note. And so this text document is located in notes and then slipbox and then index.text. So we can do something like, I don't know, say hello world. So this is from the LaTeX document. And then, so you can compile this just with PDF LaTeX as you normally would. But you can also use TeXNotes to render the the LaTeX, and the benefits of this is that you can have these kind of referenced in section. So if you just compile the LaTeX kind of by itself, then you don't get some of the extra features that are included with TeXNotes. To render it with TeXNotes, then you can just say manage.py render updates. And then this will say rendering index. And what this does is it creates a PDF file in the TeXNotes directory. So PDF and then index. And then so you can see this is our tex file kind of rendered. Another thing that you can do is you can render, you can use, instead of using PDF LaTeX, we can use make4ht. So if I do render index and then HTML, then this will render the index file, but as a web page rather than as a PDF file. So this is quite useful if, say, you want to share the notes that you make. So we now look in the HTML folder, and you'll see that we have this index page here. Okay, so now I'll show how you can link files together. So let's make a new note. Say, I don't know, vector space. Right. Then if we edit the vector space file, so you see I can change to the vector space folder, and then I can say something like begin definition. And then you could, I don't know, write the definition of a vector space. A vector space V is some set with some properties. And now what you can do is we can label the definition. So this is just like you would for if you're just writing a normal LaTeX document, then you can label these kind of theorem environments by just putting some text in this label command here. So definition vector space. Okay, and then in our index file, maybe we would say something like, we can maybe put a section, say linear algebra. And then we can reference the so then we can say something like xcref vector space. So if I have a so you see the title of vector space is vector space or vector underscore space. So if I have a note of that form, then the reference in cref will be kind of a camel case version of that. So it will be vector with a capital V, space with a capital S, and then no space between them. So we now render the updates. So manage.py render updates. And this will render the index and vector space. And then so if we go to the PDF folder again, then the updates will be rendered. So if we go to index, which we should already have open, and we have this linear algebra section with vector space, and then we can click on the vector space and it'll, has the definition and it says referenced in index. So this is the kind of clever referencing style. So basically what I mean is if I reference the definition of a vector space, and now render the updates. Then it says kind of vector space / definition1. So you see that definition1 is definition here. And so, for example, if I added something else to the vector space file, so let's add another definition. So let's say vector. Then a vector is just an element of a vector space, I suppose. So now if we reference the vector instead, then it will say definition2. So we go back to the index file. And then here we just change this reference to be referencing this second definition. Then when we render the updates, you see it goes to definition2 instead. So this is kind of a very, this is very similar to just using references normally in LaTeX. Right. So another thing that we can do is we can also use biber to use citations. So to do that, we need to kind of add our bib LaTeX document with all the citations in it. So normally so for mine, I have a kind of link to a bibliography that gets automatically rendered by Zotero. So I have a reference manager called Zotero, and this kind of automatically exports the bib LaTeX. So whenever I say add a new reference, then I can always access it in the bibliography. But so let's just copy this to our example file. So let's paste this here. And now if we just edit the bibliography file, then I can see all of the, this is going to be quite a big list of citations, but let's just copy the first one. So then go back here, and then let's just say cite. So this has added a citation, and now if we render the updates again, then this manage.py checks to see whether any citations have been added or changed. And then if they have, then it knows that it needs to run biber again. So it's noticed that a citation has been added. And then, so this has just worked with, biber. So this is, kind of very convenient to be able to, very quickly kind of reference documents in a way that you would if you were writing things to write a paper. So in Obsidian, if you want to do referencing, then I don't know, I've found that it's a bit of a mess, and all the referencing that I want to do is basically say citation key of the paper, and then just forget about it. Whereas in Obsidian, you have to kind of install a whole load of other things, to kind of get a sort of citation thing that isn't even as good as, just general bibtech. Okay, so I guess the final feature to talk about is the kind of projects. So if I say manage.py new project, then what this allows you to do, so let's just say example, is kind of combine the notes together and then kind of very quickly make a draft of a paper, or, say you want to, just very quickly share some notes or something, and then you can very quickly make a PDF document that just contains a load of things. So we go to the projects folder and then example. and then edit this example.tech. Then we have, you can see here that we have kind of transclude, these kind of transclude functions. So if we get rid of the name example note, and let's say if we transclude the index, or maybe let's transclude vector space first. So, I mean, it's a bit confusing to remember. With the transclude call, you have to use the underscore because you're kind of just, the way that this works is it's just using this kind of execute metadata command, and this takes input as a file. So because you're inputting a file, you need to use the file name rather than kind of the reference name for general referencing. So if we transclude this vector space and then we just render example.tech using PDF LaTeX. So then you'll see that we have our definitions from our export. And then a really nice feature of this transclude is that if we also transclude the index, and then render the LaTeX, then the clever referencing works automatically. So this is, so you write your notes, you have references to theorems or whatever in your notes, and then when you come to export it, you don't need to come up with a whole load of new citation keys or kind of reference labels for your notes. You just automatically have this clever referencing within the document. And then I've also set it up so that if you run biber, and then let's render it again, then the references also just work automatically. So this has been an overview of TeXNotes. So the links are in the description if you want to install it. There's also a mailing list where I send emails about any updates to this. So, sometimes I might update something in the GitHub repository because the software is still very much under development, and that might change the way that something works. So you might have to, edit some of your note files. And so if you sign up to the mailing list, then you'll know that there have been changes that might affect the way that you take notes. So, thanks for watching. And I'll make some other videos about, kind of implementing new features and new plans for this project. So subscribe if you want to keep informed about the project.